This will be for the con exercise using slope and intercepts in context. All right, it says Reagan graphed the relationship between the number of bars of music he played and the total number of times his metronome clicked. All right, so here is our graph. And we can see the bars played is the x-axis, and the metronome clicks is the y-axis. Which feature of the graph represents how many times the metronome clicks per bar? All right, the first answer is slope. Let's look at the graph and see what the slope tells us. So we know the slope basically equals change in y divided by change in x. All right, that's the slope. A lot of times we see it as the Greek letter delta x divided by delta y. Okay, same thing, change in y over change in x. And we said before the y-axis is the metronome clicks and the x-axis is the bars played. Okay, so change in y would be the change in metronome clicks. All right, so in the numerator for the y, I'm just going to write metronome clicks, or I'll just write metro clicks. And the change in x in the denominator, for the change in x, I will write bars played. All right. So you can see that the slope, which is the change in y over the change in x, will give us the number of metro clicks per bars played. All right. When you see the word per, it usually means divide. All right. Like if you had meters per second, I'll just write it up here. This is not part of this problem. But if you had meters per second, what would that look like as a fraction? Well, that would be m meters divided by s seconds, meters per second. Okay, so same thing here. This is metro clicks per bars played, number of metro clicks per bars played. All right, and I'm pretty sure that's what answer A is. All right, so I'm going to erase this and look at what they asked us one more time. Metro clicks per bars played. All right, the question asked, which feature represents how many times the metronome clicks per bar? Metronome clicks per bars played, that's what we said, and that is the slope. All right, so that is answer A. Coleman graphed the relationship between the number of rotations of his front bike tire and the distance he traveled past the tree. Negative distance means the tree is in front of Coleman, and positive distance means the tree is behind Coleman. All right, so there's the graph. The tire rotations is the x-axis, and the y-axis is the distance past the tree. What does the y-intercept represent in this context? All right, let's see. First, let's actually locate or find the y-intercept. All right, the y-intercept is where the line, this is the y-axis here, The y-intercept is where the line crosses or intersects the y-axis. So that is right here. All right. And the y-intercept, I should say at the y-intercept, x equals 0. Okay, because the y-axis is right here. This is the x-axis. And if you trace the x-axis to the left, right here, this whole line, or the y-axis, is actually x equals 0. So at the y-intercept, x equals 0. And the y-intercept, if this is negative 10, this here would be negative 5. And this here would be negative 15. Okay, obviously it counts by 5s. At the y-intercept, x equals 0. So at x equals 0, y equals negative 15. And what does that tell us? Well, x is the number of tire rotations. So x equals 0, we can plug in number of tire rotations equals 0. I'm just going to abbreviate ROT. Number of tire rotations equals 0. And y is negative 15. Y is distance past the tree. All right, so distance past tree equals 15. All right, so I got these two items right here from the y-intercept. All right, the number of tire rotations is 0 and the distance past the tree is 15 or negative 15. All right, so the answer should be something like this. And notice I did all this before I looked at the answers. All right, so let me erase this and check. Number of tire rotations is 0. Distance past the tree is negative 15. Answer A, number of tire rotations it took to be beside the tree. No, because our translation said 0 tire rotations. The number of tire rotations it took to travel 1 meter. No, our interpretation said 0 tire rotations. The distance Coleman traveled per tire rotation. Again, no, because our interpretation said 0 rotations. So that is none of the above. All right, I believe most of these write-ups you probably don't even need to read. An observation point was originally in line with the top of a waterfall, but the waterfall moves at a constant distance each year from erosion. The following graph shows the relationship between the time since 1998 and the distance the top of the waterfall is from the observation point. Negative years represents time before 1998. All right, x-axis is years since 1998. So obviously at point 0, that's going to be 1998. And the y-axis is the distance from the observation point. What feature of the graph represents the distance from the observation point in 2003? All right, this one isn't too bad, because they're asking us the distance in 2003. Now, of course, if we did 2003 minus 1998, all right, that's just 5 years. All right, so this represents the year since 1998, so at 0 years, that's going to be 1998. All right, so what's it going to be for 2003? Well, that's going to be at 5 years. Okay, so right here, this is the year 2003. And they asked us what is the distance. They asked us what feature tells us the distance from the observation point. Well, we would have to take x equals 5. This is the x-axis. X equals 5 and trace that to the line. So that point right there, if we trace that to the y-axis, that'd be about 2.5. Okay, so I'm not sure what feature of the graph this is, but that's basically the point that tells you the distance from the observation point in 2003. Let's see how they describe this in the multiple choices. I'm going to erase this now. All right, which feature of the graph? Slope. Well, that point, that was just a point right here. That's not a slope. So it's not A. X-intercept. X-intercept, this is the x-axis. That's over here. Our point was over here. So it's not B. Y-intercept. Y-intercept is right here. Our point was over here. So it's not the y-intercept. So apparently it is none of the above. Last one, Beatrice graphed the relationship between the time in seconds since she sent the print job and the number of pages printed. All right, X is the seconds since sending the job. Y is the pages printed. What does the x-intercept represent in this context? All right, let's just locate it first. So this right here is the x-axis. All right, this is the x-axis. X-intercept is where the line crosses or meets the x-axis. That's right here. All right, and at the x-intercept, y equals 0. All right, because this is the x-axis, but it's also the line at y equals 0 right here. All right, so at the x-intercept, y equals 0. And this point right here, if this is 10 and this is 0, this must be a 5. So x equals 5 seconds since sending the print job. And that is at y equals 0. Okay, so 5 seconds since sending the print job. All right. 5 seconds since sending print job. We'll just write sending job. And that translates to y equals 0. We said y equals 0 and y is pages printed. So 5 seconds since sending the print job equals 0 pages printed. Okay, that is the translation right there. So notice I got the answer before looking at the choices, but the choice should represent that answer right there. A is the number of pages already printed when she sent the job. No, because it's not when she sent the job, it's 5 seconds after. The number of pages per second. No. The number of seconds that passed before the printer started printing pages. That makes sense because if you say before the printer started printing pages, the number of pages equals 0. Okay, and the number of seconds we said was 5. But they didn't have an actual number. Anyhow, that is answer C.